Hi class, and welcome back to the lecture videos again. And in this video, we're going to cover the section 8.5, and going to talk about what is expected values. Okay, so the expected values, what what is that means here, right? So I want to give you one very simple examples, and then you will say, oh, that's why the formula makes sense. So the first thing is here. Okay, so let's take a look. I want to give a definition first. Then we're going to take a look at the expected value. So the definitions I'm going to give first, we'll call it the random variable. Okay, so for the random variables here, you can always you can say random variable x, random variable y, or random variable z, whatever. So you can always use the capital letter to represent the random variables here. Okay, so what is random variable? So the random variable is really it's kind of like we call this functions. And these things that assign a real number to each outcome of an experiment. So what that means here, so let's take a look for examples here. So if I toss 2 coins, right? So if I toss 2 coins, and we know we have that, we said we did this many times. We said we have a tail, tail, head, and head, tail, head, right? So what is random variable? You can say, okay, now I'm defining a random variable x. So what is random variable x? That means I can define it, say, hey, I define a random variable x is the numbers of heads. Okay, so in this trial, I can define the random variable x is the number of heads. So the way I write it, I can do like this, right? So here we write it like a lowercase x. So the random variable is uppercase, right? So the lowercase x is just say this is the values, all the possible values for your random variable. For your random variable x here, right? So capital X. So that means now I said x, so it's kind of like a function. So the purpose for here is you assigned each outcome into a number instead of list elements. So for the first ones here, if you have a tails, right? So your x value will be 0. Then for the tail head and the head tail and the head tail, for both these two, you have one head, right? So you put a one head here. Then for the last ones here is a head, right? So for the head, you have 2 heads here. So you put a 2's here. So that's how do we say that, how do you define random variables here? Then the random variable also associate with the probability. So the typical we do like this, we say this is the probability of X. So you say the probability of x is here, it will be, so this is 1/4, right? And then now you have 2, so this is 2/4, and this is 1/4 here. And this is what we call is the probability. So this is what we call this is the probability distribution this is the probability distribution of the random variable x here. Okay, so now what is the expected values, right? So I'm going to give you the definition first, and we'll take a look at the examples here. So the definition of the expected value. So the expected value, well, before we give you the definition, let me take a look at notation of the, okay, so let's take a look at notation. So expected value. So what do we mean expected value? So we use this notation, we say this is the expected value, right? So it's the expected value of this random variable. That means what do I expect? So before I write down the formulas here, I want to give you one very simple example, then you'll be able to know why I defined this here. Okay, so let's take a look at this simple example about the expected values. I think it will make sense and you will understand why we do that. Okay, so like in here, okay, a while ago I have to stop for a few minutes because my dogs want to, you know, keep crying, want to go outside. Okay, so I need to let her back to the backyard. But anyway, okay. So now let's take a look at these examples here, right? So what is the expected value? So let us assume, you know, in the June, we finally out this quarantine, the social distance things, and everybody's life back to normal. And you plan to have a party in the weekend at your house, right? So then you say, okay, for this party, I'm going to invite some people. So the people you said, okay, first group of the people I'm going to invite is from the high school, my high school friend. Okay, so you say, I want to invite my high school friend. Then you say, how many high school friends I'm going to invite? Or maybe I'm going to invite 10 of them. And then you say, okay, the next group friend, I'm going to invite from the friend I know from the Richmond College, right? So like I have this class, then I have maybe I will invite 15 of them. And then you say, well, I know some friends from my working areas, right? So I work part-time. So I'm going to invite some of the friends from the work. And then the people from the work, maybe I know 8 of them, right? So I know 8 of them. So I say, okay, I'm going to invite all these 8 friends here. And then now you said, okay, because then you said, well, for my high school friends, since I have not talked to them for a while, so even I invite 10 of them, probably only like the maybe 20% of them are going to show up because we have not talked to each other for a while. So maybe only 20% of them are going to show up. And then for the Richmond friend, you said, hey, for the Richmond friend, and since we are working, you know, we have the same class, so maybe 1/3, right? So 1/3 of them, so it's 33%, or 1/3 of the friends going to show up here. Then for the work, you say, well, for the work people, and they work pretty hard, maybe only 25%, so a quarter of them going to show up. So that means 1/4 of them going to show up. So you know you invited 10. So total, how many you plan to invite? Total, you're going to invite 25, 33. But you know not everybody will come. So you estimate, so the high school friends, so now you are the host, right? So you need to prepare how much drink you have, how much food you have. You don't want to buy the food for all 33, and then some food might get waste, right? Because not everybody could show up. So you say, okay, high school friend, only 20% of will come. So probably 2 of them will come. And then Richmond, I invited 15 of them, probably 1/3 of them will come. So probably have 5 people will come here. And then the work, you know, is maybe a quarter of them will come. So I invited 8. So how many you know, probably will come 2 of them. So when you add this up together, so when you add this up, right? So how many you have? 9. So what is this 9? This 9, that's what we call is expected. So you expect, this is what we call the expected values, right? So it's kind of like you expect 9 people will come, right? So you invite 33, but each person, they have a different, you know, probability they will come or not. So you kind of expect, right? So 9 people. So of course, not exactly 9 people will come to your party. Probably we'll have 12, probably I'm have 8, right? So going to be arranged, you know, different around that, but you know, you expect 9 people will come. So the most safest way to prepare your meal probably is say, hey, I'm just going to prepare 9, you know, the enough food for 9 people. If the people show up less than 9, I have a little bit extra. If the people show up more than 9, so maybe each person just eat a little bit less. So that's what we call the expected value, right? So it's a pretty simple idea. How many you have, you times the probability, then you add them up, right? So now this is how we defined our expected values here. If you go back here, so the expected value, so basically, this is the formula. Like I said, I'm going to go back here for the formula. So will be the summations, right? So the value of the x times the px. So everybody still remember what is this sign? This is the Greek letter. So what is this sign? This is a summation, right? So basically it will tell you, you add each up, right? So you add each up, you times it, then you add them up. That's what is the expected value means. So that it's just like our party, you know, like our party example, sorry here, right? So that's just like our party example. You invited the 10, but it was 10 people, only 20%, so it's 2. So you add it. That's what we call is expected values here. All right? Okay, so it's a very, very simple definition. So how much you expect, right? Okay, now let's take a look. Okay, so let's take a look at some examples here, and then let's see if we be able to get it or not, right? So here, this is the examples here. Oh, what happened? Okay, so this is the example. Example number 1 is here. Okay, so we said the 4 coins are tossed and the random variable x is defined as the number of heads, right? Okay, so for here, so now we say I tossed the 4 coins, and now the random variable x is the number of head. So find the expected value of x. That means if I toss, you know, so if I toss like the 4 coins, how, you know, like what is the expected values I'm going to get? So let's take a look here, right? So the 4 coins, right? So if you toss 4 coins, so you have 1, 2, 3, 4, right? So first is in order to get the expected value, I need to do a distribution table. So this is the PX, right? So if you 4 coins and the axis here is the number of head, right? So now you know the x could be what? 0. That means all the 4 coins are tail. Then you can have 1 head you can have 2 heads, you can have 3 heads, or you can have all 4 heads here, right? And then the probability get the 0 head. That means all of the 4 coins are tail. So the probability, this is 1/6, and this is 4/6, and this is 6/16, I'm sorry. And this is 4/16, and this is 1/16. Okay, and then one question you ask, how did you get those probability? Okay, so how do I get those probability? I use the binomial PDF. Why is binomial PDF? Because this is a binomial trials, right? So I have 4 coins, so n is equal to 4, and the chance to get the head is 1/2, right? And then the x is the success, it's the number of heads. So that's why you put it into your calculator when x equal to 0, x equal to 1, x equal to 2, x equal to 3, x equal to 4. That's the probability you can get. Okay, and then like the expected value of x, right? Is just like we talked before. So this will be 6 times 1/16 plus 1 times 4/16 plus 2 times 6/16 plus 3 times 4/16 plus 4 times 1/16, right? So if you put this into the calculator, and then you will get it's a 2. It's kind of intuitive truth, right? So if it's kind of intuitively true. If you toss 4 coins, how many heads you expect? About the 2 heads, right? So it's kind of intuitively true for that. So that's what we said is expected numbers here. So now let's take a look at the other one. Is a little bit more complicated ones here. This is example number 2 here, right? Okay. So the example number 2 here is tell you 2 cards are drawn. Okay. The number defined and random variable x is defined as number of aces is, okay, number of the aces is here. Then I want to find expected value, find the expected value of x, right? So now let's take a look what I have here. Okay, 2 cars. Okay, so 2 cars. Oh, I'm sorry here. I think my examples here is tell you the 3 cars. That's fine. 3 cards are drawn. The random variable x is the number of aces, right? So now you said I have I draw in 3 cards here. Or car is not a circle. Haha. So like if you draw in the 3 cards here, and the random variable x defined as number of aces. So now let's take a look at this problems here. So here, this is the x, this is the px, right? All right, and now I have 3 cards. So the number of aces could be 0. Number of aces could be 1 aces here, could be 2 aces here, or all the 3 cards are aces here. Okay, so now what I need to find, right? So now in here, we are going to use the counting principles. So because I'm drawing the 3 cards So my denominator is 52 over 3, right? So I take the 52 over 3. And now if I draw in 0 aces, right? So if I draw in 0 aces, that means the 3 card I draw is none of them is aces. So how many non-aces card? Okay. So how many non-aces card here? We have 48 cards. It's non-aces, right? Because the aces have a 4 as a set, right? So that's why. So out of the 48, I draw 3. That what is the 0 aces. Okay, now let's take a look at these ones here. If it's C52 to a 3, I draw 1 aces here. I draw 1 aces. So one of them, this one is drawing. That means out of the 4 aces card, I take 1. Then, because I take the 1 from the remaining 48 non-aces card, how many I'm taking? 2, right? Because I told to draw 3. And then in here, the 2 is the same. So it's 52.3 here. All right. So now you said the 2 cards here. So that means out of the 4, you take 2. Then remaining is 48, you take 1, right? Then the 3s here, then this one is the same things here, is 52. You take 3. So that means all the 3 cards are aces. So that means out of the 4 aces card, you draw 3. So that's what is the probability distribution. Then if you calculate, use your calculator to figure this one out, and then you will, so the expected value will just be, you know, the each one's here, right? So 0 times this one, 1 times this one, 2 times this one, 3 times this one. Then you add them together. That's what is expected value. And we're not going to do that. It's a little bit kind of tedious here, right? So, but you got the ideas, right? And now let's take a look at the next ones here. Next example. Let's just do some easy one. Okay, so this is example number 3. Okay, so example number 3 tell you a local used car dealer gets a complaint about his cars as shown below. Find the expected numbers of a complaint per day. Okay. So for this example, we said, hey, you know, like, you know, that this used car dealer, and he will get different complaints. So what is this one means here? That means here, right? So here, for any given days, X is the number of complaints, right? So sometimes he will get 0 complaints, sometimes he will get 1 complaint, sometimes he will get 2 complaints, sometimes he will get 4, sometimes he will get 4, 5, and 6, right? And the chance for the car dealer to get a complaint, for the 0 complaint is pretty low, it's 0.02, and the 1 complaint is 0.06, 2 complaints 0.16, 3 complaints 0.25, and the 4 complaints here is 0.32, and the 5 complaints here is 0.13, and the 6 complaints here is 0.06, right? So I want to find what is for any given day, right? How many complaints he's going to expect. So that means I'm looking for the expected value. Every time you seek the expected value, will be pretty easy. You just use the number times the probability. So it's 0 times 0.02 plus 1 times 0.06 plus 2 times 0.16 and plus 6 times this is 0.06. So you will get 3.42. Okay, so that means on any given day, you expect the complaint is 3.42. And then you will say, hey, I cannot have a 0.42 complaint, right? That's correct. So I cannot say 3.42, but the expected value, what that means here, right? So that's really means here. So like maybe today you will get 2 complaints, tomorrow you will get 4 complaints, then the other day you will get 3 complaints, and then like here. So the expected value really means, you know, like we call it, that's what we call it, it's a long-term kind of the average. That means if you do this every day, so today you get 2, tomorrow you get 3, other day you get 1, other day you get 6, blah, 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 right? So that means you really, on the average, you expect, you know, you will get about 3.42. That means, you know, the number of complaints should be jumping around these ranges here. Sometimes you get 3, sometimes you get 4. Then the very, very rare chance you will get 6. Also, very, very rare chance you will get 0. That means on average, right, you will get 3.42 complaints. That's what we mean, the expected value. Of course, you cannot get a 0.42 complaint. That's just the averages here, right? Okay, so now let's take a look at other ones here. So this is the examples here. Okay, so this is example number 4. Okay, so in a certain animal species, the probability that a healthy adult female will have no offspring in a given year is 0.29. And you know, given year, let's put it here, we have let's put it this way, the healthy female will have numbers of offspring in the given table. Then I want to find the expected number of offspring. Okay, so here they give us a table here. All right, so that means for the certain animal species here, and I'm going to have here this female adult, the chance and the probability. So the chance to have no offspring, 1 offspring, 2 offsprings, 3 offsprings, 4 offsprings. The chance to have no offspring is 0.29, and this is 0.23, and this is 0.18, and this is 0.1623, and so it's 0.16 and 0.14. Okay. Okay, so I want to find the expected value of offspring. So as soon as you see the expected value, it's the same thing. You just use the probability times the value. So it will be 0 times 29 plus 1 times 0.23 plus 2 times 0.18 plus 3 times 0.16 plus 4 times 0.14. So you will get a 1.63 offsprings here. So this will be our answer. So expect to get a 1.63 offspring. So it's the same way, you know, you cannot get a 0.63 offspring, right? So, but that's what we said, the expected value is long-term average. So like some year you will get 1, some year you get 2, some year you get 0, some year you get 4. But after many, many years, the long-term average, the average is 1.63. So that means you kind of expect, you know, they will have between 1 and 2 offsprings every years, right? That's what we mean the expected values here. Okay, so now we're going to do one more examples here. This example is kind of like a very interesting example, like we saw that. I'm going to use one of the, we all know, right? Okay, so here. So this one's here. Right? Okay. All right, so we all, I don't know you guys old enough to play the Texas Lottery or not. And so the Texas Lottery, there's a game called Pick 3. I don't know if you guys know or not. So the Pick 3, all right, so what's that means here? That means you choose, okay? So you can choose any 3 numbers. Okay, from the 000 to 999. So like you can choose 111, 121, 312. So you can choose any numbers from here. And so now if your number matches, if your number comes up and you win 500. Okay, so you win 500 and you pay $1 to get a ticket. Okay, so in fact, for the Texas Lottery, if, I think the Pick 3 is the one has the better chance to win than like the real lottery, like you need to match 6 or 7 numbers. You will see why, right? Okay, so let's take a look. So I want to find what is my expected gains here, right? So you pick 3 numbers, right? So in here, so it's how much you're going to win, right? So you are going to win $500, right? So you're going to win $500. And what is the chance? The number from 000 to, take a look here, from 000 to 1999. Total, how many numbers? Total, how many numbers you can choose? 1,000, right? So including the 0, right, to 999. So in total, 1,000. And you only choose 1. So the chance for you to win if you choose the right ones, right? So it's 1 over what? 1 over 1,000. If you choose any other number, what happens here? You're going to lose the dollars, correct? You're going to lose $1. And what is the chance you're going to lose $1? Well, you're going to lose $1 is what? It's 999 for the thousands, right? So all the 999 numbers will not be correct. So you're going to lose $1. So this is what is your expected payback, right? So this is how much you expect to pay back, right? Okay, so now you see here, okay, so that's really is the expected value. So you use this times this, add this times this, right? Okay, so now it will be 500 times 1 over 1,000, then plus -1 plus -1 times 999 what? 1,000. So this will be 500 of the 1,000 right? And minus 1,999. So what is here? Negative 499 over 1,000. So it's about a negative, it's about a negative 499. So this is pretty close to 50 cents, right? So that means you expect to win or expect to lose? You expect to lose. How much you expect to lose? You expect to lose about 50 cents every time you play. So this is not a fair game, right? Because you expect to lose. So think about it. If so many people play these games, everybody expect to lose 50 cents. And so like in here, you think about how the Texas Lottery Commission make money, right? So if you think about it, if I have 20,000, not 20,000, I have 20,000. Okay, so if I have so if I have 20,000 people to play this game, to play the pick threes, right? So if I have 20,000 to play the pick three, and then what is from the Texas Lottery they expect to get? They expect to get what? They expect to get in the long term is $10,000 every time when they play that, because the other people expect to lose 50 cents. That means you lose to the Texas Lottery Commissions, right? So that's why so it's a good business. That's why a lot of states, they have the lottery, and it's pretty good income for the state, because the chance for the people, to lose money it's not a fair game. So the people play the lottery always lose the money, or the Texas Lottery Commission will not be able to survive. So if you want to figure, what is the chance you will match all the 6 number to get a jackpot, that's really very, very small, right? So even you can reach like several $1 million, but still the expected value is very, very small. If you can use the calculation, you can do that. Okay, so that's it. This is, we totally wrap up what we have in the chapter 8. This is a chapter 8, right? So it's kind of like we talk about the chapter 7 and the chapter 8. We did a little bit about the statistics. So it's kind of like give you a little taste of what is the probability statistics about. Like we mentioned, this is a very diverse class, right? So we cover many, many topics, and they'll give you some like marketing finance topic. We talk about interest, annuity. Now we talk about the probability and some statistics. So that's it. So that's for the chapter 8. We did not go deep. We go to very, very top surface, just to give you some awareness. And then the next chapter we're going to hit is chapter 10. Chapter 10 is kind of like the algebra chapter for this class. So the chapter 10 is if you are taking the 1325 calculus, business calculus, and the chapter 10 will be a very useful and important chapter for you, because they give you the necessary algebra skill you need for 1325 here. Okay, so I'm going to wrap up the section 8.5. So make sure you do the exam number 3 review and watch the video, understand how to do each province here. Okay, and so I wish you good luck, and that's it. Okay, so then the next video we are going to talk about, we're going to start chapter 10 here. Okay, nice to talk to you again, and take care and be safe. Bye.